All right, today we're going to take a look at linear inverse functions. We're going to deal with other inverses other than linear functions, but today we'll just talk about linear inverses. One thing we need to recognize that if you ever graph a linear inverse, what you'll notice is that it is reflected across the y equals x function, and there is also an inversion of the ordered pairs. What I mean by that is if I have an ordered pair 2, 3, the inverse to that is going to be 3, 2. In ordered pair -1, 5, inverse of that would be 5, -1. So that's something you can keep a look on as we're doing these. All right, so we discussed what an inverse function is. This is how we actually do it. It's really an easy process. All we've got to do is switch the y value and the x value and then solve. So this is the y value when we say f of x. So what we will do is we will substitute that value for the x function and rewrite it. So what it's going to look like is this. We're going to put the x here, and then we will put the, you're supposed to put a y, but a student showed me some time ago using an f is actually a real easy and neat way of doing it. So we're going to do this, and what we do is we resolve for the f value. So the first step we need to do, just like any linear function, is get the 16 away from it. And it doesn't really matter which side we put the x on. I like to put it on the side that's easiest. And in this case, the easiest side is going to be there. So we get that. And then lastly, we divide by -4. Divide both sides by -4. Now at this point, we could see it multiple ways. We could see it written as a very common way of f, in the way we write inverse functions, is f to the -1 power. That is not a mathematical operation. It's just an indication that we have an inverse. So this is one way. We could also put the negative sign not in the denominator, but in front, which is a very common way. And then the last way we might see this is to actually take the terms and divide each of them by -4. So x divided by -4 is -1/4 x, and 16 divided by -4 is -4. And again, if you wanted to check this answer, what you could do is put this into a y equals and take this and put it into a y equals. And if they are reflected across the diagonal line, and if their tables are inverted, then those are inverse functions. So the next one we're going to look at deals with a function that has a fraction in front. It's still the same process. Like I said, the process is nothing very difficult. We are going to rewrite this function, but in place of the f and the x, we're going to substitute these values. And again, there's usually a y used here, but like I said, I had a student show me this, and most of mine have a better job doing it this way. So we have another 16 in this case. So we get x minus 16 equals -4/5 f. So at this point, what we have is two operations, but we can take care of it in one fell swoop. 4/5 is the same thing as saying times 4 divided by 5, so we could do that one after another. But what I would prefer to do is take this and multiply times the inverse. The reciprocal of 4/5 is 5/4. So what I'm going to do is multiply both sides times this. The reason why I would do this is the 5 cancels the 5, 4 cancels the 4, and the negative cancels the negative. So I end up with the f by itself. On the left side, this is a version of the answer. Another thing we can do is to actually distribute the 5/4 in. This is probably going to be the way that you generally see it. So we end up with negative 5/4 times 16, negative 16. Remember, the 4 is going to cancel with this, so what we end up with is plus 20. So this would be our inverse. And the last one we'll take a look at here, kind of the same process. Just want to introduce one that had the negative sign for us, so we're going to do that. We switch our values. And then we solve for f a second time. There's really not a lot of arithmetic going on in this because there's usually not any like terms. So we end up with negative 1/2 f. Remember, the inverse to 1/2 is positive 2. And we need to multiply times a negative to make sure that the negative sign also goes away.